thought at least I sent a link somewhere to that, like an issue. Yeah, so let me maybe share my screen and then at least you can see what I'm seeing. So you should be able to see my screen now.
Yeah.
So I provided a link here. I guess that was the well, I guess the idea, so one issue is language server, and I think we have a separate point for that, so I'll skip that. So except the language server, the issue or the idea to brainstorm is currently FPM just calls the compiler file by file and just compiles it to a mod file or object file and just kind of does it separately. The other idea how to do this, or in addition, the way we can do it is we can hand over to the compiler a JSON file with all the all the files that have to be compiled and where and all the options. And then the compiler itself can take it from there. So for example, it doesn't need to be saving the mod files, or it doesn't need to be, it can go a lot faster. So that kind of would be the motivation. And also the compiler would know where to, well, it can be more in control. So I can imagine, well, I guess speed would be the main motivation for this. The language server, that's kind of the next point, but for that, the motivation is there too. Let me see what yeah, I'll just combine the two. So the language server issue for that, so the language server, maybe I'll start with that because that's kind of the most general case. So the idea is for a VS Code to be able to if location information and like print, kind of show all the subroutines in a module and be able to find definitions of a symbol and so on. And in order to do that, using compilers robustly, and for example, I would like it to work with dependencies. So for example, that if a symbol is used from some FPM dependency, I would like VS Code or any editor to just go directly to the file from the dependency and show me the definition. So for this to make this robustly work, the language server has to work with FPM. In fact, FPM can be the main, language server can be part of FPM even. And then FPM, and then I don't know exactly the details of the protocol, but the idea is FPM would, well, somehow handle it. And so it needs to work with the compiler. And so then it kind of gets tricky. And so what I was thinking, for example, if FPM can hand over a JSON file with all the dependencies and all the files of everything to the compiler, I think, can then build the symbol table for everything, and then it can keep running in memory, for example. And then when the language server gets a command from VS Code to look up some symbol, it can hand it over to the compiler, and then the compiler can find all the files because FPM gave it all the files. If we don't do it like that, like what's the alternative? I guess I wanted to kind of ask, like, what are your ideas? How else can we implement that?
So there is one language server out there that I know of because I've been using it with an Atom plugin, and it's distributed as a Python package. So I've just been installing it. Pip install Fortran language server. So there is one out there.
Is it this one?
That's probably the right one. Yeah.
Yeah. So I tried to install it and I could not get it to work. So I installed this
Fair.
I would like it to make it work. I mean, and I would like to have it like documented and supported better. But well, first of all, I would like them to name it with lowercase Fortran or like uppercase F lowercase. But so I installed this extension, and then you have to also install, as you mentioned, the Python package.
Right.
This one, and I tried it, and I just cannot get it to work. I tried this, and it's because it's Python. It's kind of, unfortunately, I assume that I installed it under user and then the extension cannot find it. That's my guess, but I don't know how to fix it. So I'll have to work on it. But the idea is to kind of make it look like this, that you can have this in this outline. I don't know if this is Chinese or which language this is, but I think it says outline, and it gives you just that's what I would like. get to work. Except that
Mhm.
it's hard for me to imagine that this already, even after you set it up, that it already works with FPM dependencies. Do you have an experience?
I yeah, I think it doesn't know where to find the dependencies.
Exactly.
I so far I think my experience with it is that it only works once you've opened a file, because then it goes, oh, now I've seen stuff from
Right.
that file.
Right.
Otherwise, unless there might be some options somewhere to specify include paths or some things, but by default, yeah, I don't think it understands where to go look for stuff.
Exactly. Well, how can it? I mean, it doesn't know. And so
Right.
that's, and my experience with setting up this for C++, it's kind of similar. It kind of works. In fact, I can even show you what I mean. And I would like to have a better experience than that. But like I can show you if I open code in, let's say, LFortran.
Mhm.
So now it's within, so it shows, so it works kind of locally. And if I do F12, oh yeah, you see, you cannot even find the definition. So this is an experience that just, I don't want that. I want it to be able to actually work.
Yeah.
And you can see all these underlines here. That means it even says it no, it just cannot find the LLVM dependency.
Yeah.
And of course, I don't blame it. I understand, it doesn't know where to look. I think it's installed via Conda or whatever. But for Fortran, since we have FPM, this should be an operator. It should just work.
Right.
Because FPM knows where everything is. It knows every dependency, it knows every file. So it should just work. And so the experience that I would like is, and so I mean, I'll finish my thought about C++. So to get this working with C++, you have to then, like, can't remember, you have to set up, go into your settings and give it the paths for all your projects. And if you do it, then typically it works. But it's such a poor user experience. And what I would like is to just install one, let's say, VS Code extension and nothing else. I don't want to be installing any kind of Python packages. I want to just install one VS Code extension. And then I want to just open any Fortran project that uses FPM. And I would like this to just automatically work across all dependencies, files, out of the box. And I think it's doable. And so the only question is how to do it. And so, I don't know what the best path forward is.
I like the idea of having FPM kind of be between the extension and the language server, because that way, because it's really going to be able to tell where everything is and say the language server, here's where everything is, and then feed that back to the extension.
Something like that, yeah. And so I guess, we don't have to really figure out anything right now, but I just want to put it on people's minds to think about it, what's like, how we should handle it. And it seems to me, if it will be easier for FPM if we can just hand over a JSON to the compiler, hand over a list of JSON files, JSON file or whatever, maybe in either file or in memory, and then somehow cooperate with the compiler to get this work. Or the language server can, maybe the language server can ask FPM to give back to the language server a JSON with all the stuff, and then the language server can call the compiler and give it that information, and then the compiler can just get it done. Yeah, so that's any more comments to these 2 points?
Sebastian, you raised your hand for a second. Do you have a comment? Oh. We can't hear you, Sebastian.
If you are talking, we cannot hear you.
Ivan says in Sublime, you need to open your folder as a project, then the language server.
Oh, yeah.
Does it? Do you know? Is it scanning the whole folder, basically?
So as far as I understand in Sublime, you have. So I click on a tab, and then I say like open folder as project, and then he will essentially look through all the files to find the right definition and send you to the right line. So this is something where I'm not sure how, let's say if I download an FPM package, but I haven't yet built it, meaning I haven't yet downloaded all the dependency packages, I don't think this can work unless unless you do it kind of like the way Andre suggested, that in the editor, we have like the editor ask FPM, hey, can you hand me a file with all the dependencies? But at the moment, I don't have a real clear picture.
I guess one question I have is how should we organize development of the language server? Should we just maybe we can ask this project wherever it was.
So there is a standard for a language server protocol.
Yeah, well, that's the standard. But what I mean, should we cooperate with this? It would be ideal if we can. Maybe we should just ask them if they would be interested in brainstorming with us how to make this work with PM.
Okay.
And the way I looked at how they do it, it looks like they have a parser. So it's a Python package that has a parser. So I think all we have to do to get started is to just figure out how to get this working with FPM so that FPM can provide the information where all the files are. And that might be enough to just at least get it working on the level that they have. And then what LFortran and Flang and other compilers can provide later is just a better parser and just more robust, faster and so on. But that's a separate issue as far as I'm concerned. It looks like they've done a lot of, it's a lot of work. And if you look at how they, just look at the code, it's all written by hand. It's a lot of work to write a parser like that and get it working.
Yeah.
I don't even know if it works for every Fortran or if only subset and so on. But I think in terms of saving or be more efficient, I guess, I don't know the right term, is to just reuse a compiler, because compiler has to have a parser anyway, as well as semantics. And so just reusing it seems natural, that we can kind of focus on the user experience as opposed to maintaining, a parser, and keep updating the parser for every Fortran feature. Martin, go ahead.
Yeah, so I think I just want to make 2 comments. So probably these people are maybe not convinced to switch to FPM. So I guess we certainly, if we want to cooperate with them, we should run in normal mode. And the other thing is, so I currently see, of course, LFortran taking the lead here. So the question is, do you want to support like a language server based on LFortran when you actually want to compile your project? It's another compiler.
Yes, well, I mean, so I want to have a language server or use LFortran for a language server. Maybe not the only one. I don't know I'm sure. I think Flang also wants to have a language server and so on. And that's fine. We can just, all we have to do is figure out how, the interface. In fact, I think the interface is figured out between VSCode and the language server as a package, but then the language server as a library, it still needs to communicate with the compiler somehow, or it can be part of a compiler. The reason,
the idea with the language server is that there's a standard protocol that you can use for any language, and it can talk to any editor. Right? So all you have to do is write one thing that can communicate with a language server and a language server, and now they can talk to each other.
So one thing, so what I don't know is how easy it is, what the interface is, how much boilerplate, or what I'm trying to say. So let's say LFortran already is a compiler, and if you ask it, it can give you the information. But how difficult is to maintain the boilerplate to adapt it to actually communicate with VS Code using the protocol? That I don't know. But
I haven't looked at detail at what the actual protocol is, but there's more than just parse and try to compile the file. There's more to it than that. So obviously you need a parser, and so that's a big first step that LFortran already has out of the way. So,
well, not just the parser, you need the semantics, because you need to look up the symbols, which LFortran also has, and then but the difficult part, or so what I want to experiment with is the performance of. My understanding is I played with TypeScript, and the way it works there is that when you press a button, a key in VS Code, it immediately updates the symbol information, and it underlines, if you make a mistake, a typo, it underlines the code immediately. And for that to work, we need to just experiment. I don't know if we have enough time to parse the whole file or like redo everything from scratch. Probably not. And in that case, the compiler has to be running it.
I
Memory.
believe the protocol says that the editor can send change, like deltas, to the language server.
That's right. That's what I think is exactly happening. And then, so that means to make this efficient, I suspect the compiler has to be running in memory. And then
that's basically the idea. That's why it's a language server protocol. Is the language server is running in memory and keeping a lot of information in memory and just doing minor updates.
That's right. And so, and what I would like as a user, let's just start with the goal. What I would like as a user is to just type Fortran code, and I would like the VS Code to give me just the feedback immediately, like as quickly as it can. And I think for Fortran, so for C++ is tough because C++ is just kind of slow to compile. But for Fortran, I think it can be completely immediate. So that's the goal. Now to get there, I would have to experiment. I don't know if you can do it from Python like that with a separate parser. What I would imagine is to just use LFortran to just do all the parsing. What I don't know is how much. So for example, you typically modify just one file. So the project has hundreds of files typically, let's say some bigger project. So you work on one file, so you're modifying just one file. So then the compiler should maintain AST of every single other file in memory. Then maybe it needs to reparse the current file, maybe. But then the tricky part is the semantic information. What I don't know is if you have time to redo it, everything for the whole project, or if you have to be really clever and just knowing what changed and only update the stuff that changed. That I don't know, speed by performance wise. It'd be much easier if I can just redo it, but it might not be fast enough. And so in that case, and so those are kind of design decisions that would be nice to kind of work on that.
I think those are probably an optimization decision after you have an initial prototype working.
Maybe, yeah, that's a good idea. So maybe initially I should just redo everything, just get something working, and then we can see. That's a good idea. I should just do that.
Maybe this is also a good topic to have for like the next round of this Google Summer of Code, because I think this is one of those areas where we also need support from programmers skilled in other languages and other domains than just, let's say, the classic scientist programmer.
This is something we can do from the FPM side already. And we could think about having something like a FPM serve command, which runs FPM as a server and like continuously rebuilds the source in case of file changes. And if we have this information available and can make FPM run as a server, it could also provide this information to anything else. I think this would maybe be a good thing to start with, because then we have something which is also usable for just a standard command line usage, but we can get.
I think you are getting it. So I think that's the way to do it. So FPM should be the language server, and then VS Code sends FPM a file and a line and a new character that got added. FPM knows all the dependencies. So FPM knows based on the line, it knows if dependencies between modules have changed. And if not, FPM knows exactly which files have to be recompiled. And then what FPM could do is just, it can call a compiler, let's say LFortran, and only give it the files that need to, like that can possibly change their semantic information. And then LFortran, and so they can, and to make it efficient, FPM can maybe send in some kind of JSON or whatever, just kind of give it a whole, it can be just like update all the semantic information for these files and reuse everything else, and then Fortran can just take it from there and just update it and send back whatever FPM needs back to VS Code. I don't know if that's a good idea or not, but it's one way to make it work.
Yeah, I was thinking of just having something like an FPM server, which can run and provide this information in some standardized way. I'm not sure if JSON is the best thing to send, but usually you would send message pack over sockets.
Yeah, sure.
And if we get our FPM model able to serialize to this kind of format, basically the language server can be written in anything which can read from a socket. Maybe this is the simplest design to make it accessible.
And the other thing that's also part of this, and we should think about how to figure out how to do it, is, let's say the user, so a lot of Fortran codes have options like the release build, debug build, and also the kind of C preprocessor or FYPP options. So for example, let's say just a C preprocessor. Let's say you change some define. Well, that changes what things get compiled, which means for VS Code as the plugin, it needs to update everything pretty much, or whatever it needs to do to give you the right information. So how do we interact? So that's why I think it should be FPM handling it, because what I would imagine, you would just go to a terminal in VS Code. So I don't know if I still have it here. So what I'm imagining is that you would go to a terminal, and here you would just do FPM, whatever command, update my build from release to debug, or maybe let's say optional dependency. That's a maybe good example. In FPM, let's say I decide, oh, I want to use an optional dependency. So it will be in FPM toml, but maybe you can select it on a command line. So, but then in the source code, there must be some way to handle this optional dependency, either using C preprocessor or some dummy modules versus, whatever way. So FPM, so you tell FPM, I want to change my configuration. And then if FPM runs the language server, it can just update it and everything will work. If it doesn't, if it's not FPM doing it, then it needs to communicate somewhere else. But it seems to me FPM should just be running the server. It just makes a lot of sense to me. The only issue is, I don't know if there is a way for us to design it so that we can use any Fortran compiler, at least in principle, down the road as the the engine to give us back the semantic information.
I think we would need. I think we would need a parser like the one we have available in LFortran as an FPM package, which we can integrate in FPM itself.
So, for example, if we want to use GFortran, I think actually we can. All we have to do is, if you modify a file, FPM would just recompile everything that depends on it, including the file. And then all we have to do is parse mod files from GFortran, and which we already do in LFortran. We can parse only a very small subset, but it works. And the mod files from GFortran, you can extract all the semantic information about everything. I mean, so at least we'll be able to get back, the list of subroutines and so on. I can't remember right now if it includes location information in there. It might not.
Yeah, I don't think it does. And it's not going to include any information about the internals, right?
No.
So when you're editing that file, like the mod file is not going to contain the information about the internals. So I think for most compilers, you're going to require a lot of updates to the compilers before they're going to be able to support something like a language server.
At least for GFortran, we might be able to figure out from the name of the symbol how it is mangled with the module name, to which module at least the routine belongs. And if we are able to parse it, we might also be able to assign the actual symbol to the source code by some heuristics. Not sure if we will be able to figure out something like Intel or next module files, or if we actually should.
Yeah, it's something I would like to figure out for LFortran, how to design it, or what modifications we have to make, if any, to support this mode. And I think it's a very important mode, because when I think about it, it should also speed up would it speed up the compilation, or it would not? I'm not quite sure. Actually, it might, because if it runs in memory, it kind of has stuff already in memory prepared, so it seems to me it can be faster also. And so it seems to me, as a user, that might be the most important mode of operation of all. Unless you are recompiling from scratch, then of course then it doesn't matter. But if you're developing, it seems that's the mode down the road that people would use the most. So yeah.
But how would we save something in memory? If we are building with FPM as a backend, then we would still have all the build artifacts around. It only works if you're using a compiler which can completely compile in memory. If we design a Fortran like this from scratch, and then we also have the disadvantage if we close the session and start again, we are going to lose this information. So having the build artifacts in the build directory doesn't sound too bad to me.
Yeah.
As long as FPM manages them.
Yeah. The how to say, from LFortran's perspective, the more FPM can do, the better. The only question is if, as long as it can do it efficiently. But it seems so. For example, with the mod files, LFortran currently saves everything in the mod file. In other words, every single line in this ASR, abstract semantic representation form. So all the info, every line is there, all the type is there, everything, and it's very quick to parse or like load. So any compiler in principle can do that too, I think. So yeah, so what should be the first step, I guess, to get moving on this? Because,
well, we should explore how to actually implement a server with FPM. So how we can implement the FPM servers which we can run, and then implement maybe a server that runs via a Unix socket or something like this, and then as well a driver which can communicate with this. Then we have to get FPM in a mode where it can incrementally update the FPM model or rebuild the model if something fundamentally changes. And we have to make it robust, that we have a way to recover from errors. And once we are able to serve an FPM build, we should have the infrastructure to build something on top of this.
yeah.
More for questions, how would you use this in practice? So if you're running the server, it will continuously build everything. If you're running, it will just use the executable, but doesn't have to build anymore because the server already does it. I'm not sure. This would be the feature I was thinking about. So if you're saving your file, then automatically everything will be rebuilt. If you then go into a terminal, making FPM run will automatically run a compiled binary, and you don't see any build output anymore because it's already done. I think this is something we can do.
And I guess one maybe to get, so for example, FPM should be able to look up at least, let's say if you open a Fortran file and you would like to look up the symbol definition of a module. So I would assume VSCode, I don't know what the details, but I assume VSCode hands over the name of the module, asking the language server to give back the file it's in, I guess, or something like that. And FPM already has the information for this. So that can be the first step, just to see if everything works.
So the first step obviously is understand the language server protocol and all of the intricacies of that. The question of having FPM be the language server is what profiles and flags and compiler does it use for that, right? So if I've launched an FPM server that's using LFortran as the backend and the debug options, if I go to a terminal and say FPM run -- profile release, does that change the whole server to now running the release, to now doing the compilation in the background with LFortran and the release mode? Like, so what versions of the compiled stuff is the server going to be, doing the semantic representation of, and how do we change? How does the user interaction change that?
Oh, I think so. I think it would recompile everything if you change from debug to release. Oh, but you can have
Right,
both.
but my server is talking to my editor. So when I go to a command line and say FPM run the release version, does that change the server that's right? Does that change how the server is now interacting with my editor? Like,
yes, that's what I was imagining. Oh, because how else can you like what's the alternative, I guess?
The alternative would be that the editor launches its own instance of the language server.
Yeah, but how do you communicate with it?
It sets up its own socket when it launches the
but
server.
As a user, how do you tell the server to change the configuration?
Your whatever extension you're using would have to have options to say here are the.
I see.
Right. So if you want to interact with the server that your editor is talking to, you've got to interact with it through your editor. Got
it. Yeah. So that's possible, but I can imagine you have to do all this in TypeScript and JavaScript and integrate it with the editor. And every editor, I guess. What if you use Vim with that backend? The advantage of
that's the advantage of a language server protocol is most editors have a library that talks language server protocol.
Yeah, but
so developing an extension for VSCode or Atom or Vim or any of those is basically just pick up the library that talks LSP and add whatever options you want.
But does the language protocol allow, can we use the language protocol to communicate that we have added an optional dependency in FPM, for example?
Probably.
Well, I'm not, okay. If we can, then yeah, there might be an option. It might be that we would have to design the protocol for the FPM parts, because we have to encode in the protocol everything we want to be doing. Well, and if we use the command line alternative, then still, FPM, when you run it, it starts from scratch. So it would have to know that there is some language server running already. So typically you would have to have some Unix socket or something like that to communicate with it. So yeah, it's not for free either. In fact, I would say it's more complicated than communicating through the editor. Yeah, so there's a lot of stuff to resolve. We don't have to resolve everything today. I just realized there is a lot of stuff we have not even thought. I have not even thought about, and we should kind of have a good solution here and start kind of working on it. We don't have to have all the details, but having a design would help. Yeah. Okay. Any other comments? Yeah, so to conclude for this part, I think we should just kind of learn how to write the language server and see how we can hook it up to FPM and just go from there, I guess.
Yep.
And so the last part is I wanted to show you the update. Well, I'm on a new Mac and on the M1 Mac, and FPM doesn't work when you install it through Conda, unfortunately. Although I guess since we are here, I can maybe probably try to just compile it, see if it works. I have it here. Oh, that's right. But how do I compile it if I don't have FPM? All right.
You can grab the single source code version.
Or you can just run the install script, which will compile for you.
Yeah, which is exactly what that install script does. It goes and grabs the single source file version and compiles it and then builds.
Perfect. Well, let's see if it works. If it doesn't, we need to fix it to make it work. There you go.
Uh-huh.
Is it? I don't know what is. Oh, maybe it works. That's amazing.
Yeah, looks that way.
That's impressive. Very impressive.
Cool.
I found out that Fortran actually does not build on the M1 Max, but the way Cortana does it, they cross-compile from Intel. That works, and Fortran can compile natively. But if you build it, if I build it from source code, it doesn't work. So it's
Right.
like amazing. Anyway, so that's great. So now we have it.
Make-
How do you actually? I have a question for you guys. How do you put FPM in your path? Do you copy it? Do you copy it from the build directory, or how do you do it?
I do FPM install.
And what does it do? What does it install it?
In .local,
By default in .local.
Okay, so I'll do. So I first have to get FPM in the first place. So
it's
now,
already installed in your .local bin.
oh
Yeah, that's what the install script does. Yep.
oh, so it's local bin.
Yes.
Yep.
Oh, cool. So I have to put it in my path.
Yeah.
Cool. Well, what do we do?
And that's probably why the Fortran language server isn't working for you, because
because it's not.
it's not. It put it in .local bin, but that's not in your path.
Let's see if I just link it like that, if it's gonna work. Okay, everything works. Cool. So we have FPM. That's great. That was very smooth. One thing that I really want to do is figure out how we can hide these messages and just use cargo style, just the package name or file to compile and so on. So so FPM should work. Last time I tried, it works with LFortran, and so we have this. I guess I have to clone it. I created this demo. Examples. So let's see if it works. So Fortran already is in my path. So I'll do FPM build compiler. Nice, and then we'll do FPM run, I guess. Oh, and then run app, I guess. Available names. That maybe I'll just do it by hand.
You can run all. You can use the option.
That's
then I think it will run all.
There we go. Yeah, cool. Yeah, so that works, and so this is amazing. It just pretty much works. I've shown this demo at the Fortran code, so I don't have to go into too much details, but it's just nice that it works. And then what else we have on the updates? Performance comparisons. I did try this black skulls example that was posted on this course. Well, you can look up on the discourse, and I just cloned the repository, and the changes I had to make. Don't see the changes. So I just wrote a compile script to actually compile with Fortran and LFortran. So if I just run the script, let's see if it works. Oh, okay, I see. I have to do. Yeah, I have to revert the change. I was working on some. I was hoping to not have any changes at all, but I'll just do it like that. Hold on. This is using Fortran for now, and so it's an example that just runs the the kind of black skull formula. It's not vector. It's not an array operation. It's just kind of running a simple function that just computes some kind of mathematical formula, and it runs it in a loop. Just kind of just kind of like that. And then if I go to the compile script and comment out the G4tran bar, hopefully it works. Okay. And so you can see time-wise. So first of all, I get the same answer. That's the C. That's so LFortran gives the same answer as G4tran. And then in terms of the elapsed time, it's the same or even a little bit faster, I guess. And that's all thanks to LLVM. And this is another, so this is the second example which I tested performance. What's nice about this is that it was written by somebody else. I did not do anything. All I had to do is, there it is. So at this point, the only modification I had to do is just, I'm still working on implementing keyword arguments. So I had to change them to just regular arguments. But otherwise, that's the only change I had to do. Everything else compiles out of the box, and the performance, as you can see, is extremely good. Like G4tran with all the optimizations on, gives the same result as LFortran through LLVM, and all the optimizations come from LLVM. Currently, LFortran doesn't do any optimizations on its own. We are planning to, but for now it doesn't. And the fact that LLVM kind of as badly, kind of like straightforwardly generated for the Fortran code, can optimize it so well that it can compete with G4tran is just amazing. So I did not expect that. I thought it would be much slower. So it's just amazing how fast you can get just by using LLVM for this simple, non-vectorized test. Yeah, so we've done that. Oh yeah, we have the C preprocessor that I can show, I guess, on. Let's see. I have some examples here. So yeah, although like it defines and if defs and these kind of things, asset statement. I'm going to show here. So like if defs works, define work, line, file, that all works. So if I do, you have to enable it with CPP. And when you do, I'll show you them. So it's this line that fails, and this is a macro that's included from this header file, and in that header file you saw it. It's this simple kind of C preprocessor stuff, and it prints the file name and the line. You can see it prints the correct file name and the line 13. I think it's the correct line. So you can imagine there's all kinds of stuff running behind. So line 13.
Does this do you have your own implementation of a C preprocessor or?
Yeah, unfortunately, because to get the line information correctly, you need to be able to get not just, well, if you just want the line, that would be possible, I think, but this works better than that. It works, let's say with some, it works actually character correct, like it gives you the exact character. I have an example here. Let's say in this case, so it creates. I'll open it in an editor so you can see the syntax highlighting. So it defines a macro that has some variable that's not defined, and then we are using the macro. And so if I run this, so to get accurate, to know where exactly the columns correctly through the macros, you need to know how to map every character to every character correctly. And so as you can see, it's not as good as it can be. It should, so it gives you the place which fails, but it. Oh, sorry, my bad. This error is I forgot to turn on the preprocessor. So this error just shows that the symbol X is not defined. But if I do it with if I enable preprocessor, you can see it still gives you the correct line information and column information, and of course now it's expanded. What I would like to do eventually, it's not high priority because not that many codes, like the macros are not, fortunately not used as often, but it should also show you the definition of the macro and what it was expanded to, and more information. But it's a good start. Yeah, I had to implement it. For that reason, I had to implement it, unfortunately, the processor from scratch. Well, and I guess that leads to the error messages. So that's something that I was kind of wondering what are, in fact, well, I was kind of figuring out what tool is giving the best error messages. And one of the best tools is Rust. And I have some examples here.
Yeah,
Like,
Rust has spent a lot of time improving the error messages from their compiler. The
so,
language that I have heard gives absolutely the best error messages is Elm.
Yeah, Elm. That's right. It's Rust and Elm. And besides those two, I don't know, like everything else is kind of second leak, So the first leak is Rust and Elm. So that's right. And in fact, Rust implemented them by Elm, or like they got inspired by Elm. So Elm might have been the very first. And so I was kind of thinking, so how does Rust do it? And so there's some source code, and when you run it, this is the error, those are the error messages you get. The way they do it is that they have a primary error label in red and a secondary error label in blue. And you can see also for primary, they use those carets, and for secondary, they use dashes. And they also, and the way I don't know if it's the right way of thinking, but the way I think about it is that you can think of it as having an IDE. So imagine having a source code, and then you annotate that source code with these labels. So what you see here is that's your source code. This is line 4, 5, 6, and 7. So it's like 4, 5, 6, and 7, including the white empty line. And if I put something on that line, like if I put something in there, it appears here. So this is your source code, including some, if I would say like a diff. If you have a git diff shows you some lines above and below your patch. So this is kind of similar. And then it annotates the source code with those labels. And then I was reading blog posts from Rust how they how are you supposed to like read it or create error messages? And they say the primary error label, it should give you what happened in kind of a short way, but clear but short way, what happened, like exactly where is the actual error. And the secondary is why it happened. So for example, in this case, it just says that there is a second mutable borrow, and it's an error in Rust. But why there is that error, those are the blue lines. So then you can see, first happened here, and I guess here, and and then it can annotate also with some kind of like help messages, like unused, it gives you warning if you have an unused document. I don't know, like so it gives you really cool stuff. So then you can have notes and help. So I figured, well, that seems like a nice start. So that's what we've done too. And so I have some demo for that, I guess, in the error directory too. So for example, redeclaration. So as you can see, it gives you where the error happened in the redeclaration. Oh, I should show you the file itself, I guess. So I just declare it's an integer and a real again. So it gives you the error, and then in the blue it gives you the original, the secondary error label. As you can see, I have semantically, like creating the error and the labels, that's done. But to actually render it correctly, it's a lot of work, because you have to. It depends on like the file. It depends where the lines are. So as you can see, I need to flip it. I haven't done it yet. But one thing, well, and then I realized maybe not everybody would like error messages like that. I just don't know. And so the other thing I'm thinking is to have it configurable and be able to render it in different ways. So this is kind of the way I kind of like this way, because I like the way Rust gives the error messages. So I think this might be the default, but I was thinking adding a command line option that you can select maybe short messages, and the short messages can be the traditional just error and line, or maybe you can print the carets, but that's it. No secondary labels. That way people can choose. I don't know what are your opinions on error messages? How do you think they should look like?
Like, that one is awesome. Like, I've never seen a better compiler error message for something in Fortran. Like, yeah, if you could flip those back around.
Yes.
Yeah, then you're like top level there. Yeah, I would look into the design for how Rust actually generates their error messages.
I did, yeah, I did.
Because they're well, I don't mean like the formatting and stuff like that. I mean like when the Rust compiler encounters some sort of a semantic error, like there's clearly like it's getting a lot of information, and I'm curious to see how it
Yeah.
goes through and
Yeah,
So-
I kind of got inspired exactly how they do it. So
Yeah.
they have a diagnostic Rust class, and they have a
Uh-huh.
level, they have a stage. They don't have the stage that's kind of Fortran specific, like if it's a
Okay.
preparser or so on, but they have a message. They have the labels.
Uh-huh.
The labels are, and label contains,
Mhm.
well, I guess you can see it here. Label contains, if it's a primary or secondary, it contains a message, and it contains one or more spans.
Uh-huh.
And that's pretty much it. Rust. Oh, and then I guess there is also parent and children. So the parent diagnostic is the main error message typically, and then children can be help and notes, and you can kind of keep attaching elements, and each of them can also have a primary, secondary label. So it's very simple from this perspective. The hard part is to render it in a kind of a consistent way.
Okay.
That's turns out to be the hard part. Yeah, here is how it looks like if it's for undeclared variable. And the one thing that I realized, I was also curious what you think, is this one. So if you declare array here and here, I realized compilers don't warn about that typically. They
Really?
just let it like so G4.
Oh, that's true.
So it's not an error. I thought it's an error, but I don't think it is an error.
No, it's not an error. So you can put the dimension because you can declare multiple variables on that one declaration. And if you specify the bounds on the or dimensions on the variable, that overrides the previous
I was
attribute.
wondering about that. So I tried this and it just
Mhm.
worked. I just didn't know what is it even doing. So what you're saying, this takes precedence over
Yes.
that.
Yes.
Oh, I didn't know that.
Ah,
You
funny.
see, I thought it's an error, so I implemented it as an error, but I think it's actually correct. So I'll have to. What I like
I
about
mean,
this error,
we would
it
need
has
to check what is correct. I mean, no one
Yeah.
tells us that G4Run is doing the right thing here. Most likely, but
you'll have to double check the standard on that one, but I believe that's the way it works.
so I'll have to fix it. What I like about this error, it gives you the two spans for a label. But unfortunately, it's not an error, so I'll have to redo that. I have to find a different error that can give me two spans like that. But it's kind of nice, Anyway,
It could be a
you might-
warning, right? It could be a warning.
it
Yeah,
could
it
be
could
what?
be, yeah, could be a warning.
Oh yeah, sorry, I was
something like surprising or
Yeah.
questionable. I love Nag. Nag has a label that they call questionable, which
That's
just
good.
is a great word to use when you see code like that. You're like, did you really want to do this? But I would look into I don't remember the exact term, but it's something like document builder patterns or something like that. There's some patterns out there to help putting together like documentation, strings like this kind of stuff in a more convenient form. It uses a lot of like intermediate types and representations. So you might look into something like that.
Is it like a way how you render the message or how you represent the
Right.
message?
Right. So instead of like directly rendering from whatever your message types are into a string, there's like this intermediate representation that's like add some spaces, put vertical space, and allows you to like compose some sort of like document in a way where then when it goes through that structure gets rendered into a string in the correct format.
Mhm. Well,
I've seen it used in a lot of Haskell libraries, but I've never really dug into it enough to really understand exactly how it works all that well.
the other thing to think about is how do we want to get error messages in the VS Code? Since we talked about it, like how would that work? Because this is terminal, of course, but the same semantic error stuff should get passed through the language server to VS Code.
Right. Yes.
That should be a code. So it should underline the code. I think. I imagine, like when we see this,
Yeah.
it should just underline it.
So you'll take the same kind of semantic information that you're generating the message with, but there's a way to pass it through via the language server protocol that says, here's what line this goes on. Here's the part of the line you should underline in red. When they hover over it, here's the message that you should show. Like there's a place to put all that information from a language server protocol standpoint.
So as a user, that's what I would like. So
Yeah.
cool.
Yeah, that would be fantastic if I could hook up a project using LFortran via language server protocol and render messages like this. Like that would be the dream programming environment for Fortran.
Cool. That's all I have.
Very encouraging.
Yeah, very nice. Very nice. Oh yeah, it's already 10 actually here. If there are no other urgent points, then I propose that we close the meeting.
Mhm.
And thank you, Andre, for showing all these nice feature, nice progress.
Yeah,
Thank
good
you.
work. Congratulations.
Thank you.
Good. Thank you, and see you in 1 month then.
All right. See you all next time.
Thank you.
See you.
Bye.
Yeah.
Bye. Goodbye.
Bye.
Bye bye.